Hey guys, welcome back to our channel. This channel, Average Science, is all about trying to learn various concepts of science by practicing a lot of questions. In this video, we are going to solve this question on Leetcode regarding find stores with inventory imbalance. The difficulty level of this question is medium, and I'm going to share the SQL schema as well as the Panda schema in the description box below. Okay, the question reads: we are given a table called stores with three different columns: store ID, store name, and location. Store ID is the unique identifier for this table. Each row contains information about a store and its location. Secondly, we are also given a second table called inventory, five different columns: inventory ID, store ID, product name, quantity, and price. Inventory ID is the unique identifier for this table. Each row represents the inventory of a specific product at a specific store. We are asked to write a solution to find stores that have inventory imbalance. That means stores where the most expensive product has lower stock than the cheapest product. So for each store, we need to identify what's the most expensive product and its quantity. Similarly, what's the cheapest product and its quantity? A store has inventory imbalance if the most expensive product's quantity is less than the cheapest product's quantity. Then we need to calculate the imbalance ratio. That means cheapest quantity divided by the most expensive quantity, and then round the imbalance ratio to two decimal places. And we need to only consider those stores that have at least three different products. And then finally, return the result table ordered by imbalance ratio in descending order and then by store name is ascending order. So yeah, it looks like it's a lot of information, but let's go through this example. I think that will make this more clear. So here we have five different store IDs, their names and locations, and then we have the inventory table. Let's look at store ID 1. So store ID 1 has four different products, right? Laptop, mouse, keyboard, and monitor. Then let's look at which product is the most expensive. So it's laptop, the quantity is 5, and the cheapest is mouse, the quantity is 50. Now, this is a perfect candidate for our store where we have an inventory imbalance. Why? The definition of inventory imbalance is most expensive product's quantity is less than the cheapest product's quantity. Most expensive here was laptop, the quantity is 5, which is less than the cheapest quantity. Hence, store ID 1 should be in the output. And if we look at our output, we have store ID 1 where you have the most expensive laptop, cheapest mouse, and then you can also calculate the imbalance ratio. 50 divided by 5, that is 10. Right? Okay. So, to solve this question, what we need to do is firstly, we need to find that for every store ID, what is the most expensive product and the least expensive or the cheapest product. How can we do that is we can assign ranks. So firstly, we can partition by store ID. So for each store ID, let's arrange the price in descending manner and then we rank it. So rank 1 is basically the most expensive, and then we can do the same thing, but this time arrange the price in ascending order so that rank 1 is assigned to the cheapest product. Let's do that. So from this table called inventory, let us keep all the columns. So select star and then let's rank. Now ranking we have already learned that can be done by three different ways: row number, rank, dense rank. You can use whatever, it does not matter because we are only concerned about rank equal to 1 in this case. So let's go ahead with row number, and then we need to do this. Since this is a window function, you need to write over clause, and we need it for every store ID. What's the maximum price product and minimum price product? So partition by the store ID, and then let us order by the price in descending manner, and this is going to give us the expensive rank. And similarly, what we can do is we can just copy it and paste it, and in this case what we are going to do is we are going to order by price but in ascending order, right? And let me just bring it above, and let's alias this as cheapest rank. Okay, let me go ahead and run this. Let's see what do we get in our output. Okay, so if you look at our output right now, what we have here is we have all the information coming from the inventory table. However, now for store ID 1, we saw that laptop was the most expensive, so expensive rank 1, and mouse was the cheapest, so cheap rank 1. Once we have these rankings done, then we can proceed forward. So let's save this entire thing in a common table expression. So with CTE as this entire thing goes into parentheses, and then what we are going to do is from this common table expression, for every store ID we need to find out what's the most expensive product, the least expensive product, and then what's the quantity, and then calculate the ratio. So what we can do is from this common table expression we can group by the store ID and try to have one single row for each of these stores. So group by the store ID, and then what we can do is there is one factor here that we need to consider, that we only need to consider those stores where we have at least 3 different products. So since you are grouping by store ID, you need to count the different product names. So let me just drag it back to the left. You count the different distinct product names, and if that is greater than or equal to 3, that means only those stores are eligible for us. So that means you need to filter based on an aggregate, and hence you can use having clause here. So having count of distinct product name should be greater than equal to 3, right? So that is only eligible stores for us. Now what we can do is return me all such store IDs, and then you also return me the name of the most expensive, least expensive, the quantities, and the ratio. So what we can do is use case when your expensive rank is equal to 1, then you give me the product name, else it's null, end the case statement. And now here you need to understand, if you just do this, right? So for example, let's take the example of store ID 1. If your code only reads this much, what are you going to have? It is going to say that, okay, for this particular row, rank equal to 1, so it will give you the product name, laptop. But for all these, monitor, keyboard, and mouse, it will return null because expensive rank is not equal to 1, right? So it will basically be something like you have laptop and then null, null, and null. Now, here, what you need to find? You need to find that, hey, laptop was the most expensive product, right? So, how can you get that from this? You can use any aggregate function, min, max, average, sum, it does not matter. Because when you, the way aggregate functions work is they simply ignore nulls. Nulls are basically missing things. So, they will ignore the nulls and then perform the operation. So you see, that's the property of aggregate functions that we can use. So let me remove this. You can use any. Let me go ahead and use maximum of this entire thing. So basically ignore all the nulls and give me the most expensive product. And let's alias this as most expensive product. Let, it's not complete yet, but let me go ahead and run this so that it's easier for us to visualize going forward. So you see now that for each of the store IDs you have the most expensive product, and we saw that for store ID 1 the most expensive product was laptop. Similarly, what we can do is we can go ahead and get the least expensive. So everything remains the same except your expensive rank become cheap rank. Give me the product name, and this will be the cheapest product. Now what we can do is we need to also find out what's the quantity of this most expensive and the cheapest product. So in this case when your expensive rank is equal to 1, then you give me the quantity, right? If you just, let me just drag it to the right and let's go back to the inventory table. So here you have the quantity as well, right? So that is what we want. So hey, whenever your rank is equal to 1, give me the quantity, else the quantity is going to be 0. end the case statement, and if you sum this up, it's basically the quantity of the most expensive product. Alias this as expensive quantity. And similarly, what you can do is, let's copy this, paste it here, and similar stuff, that if it is cheap rank equal to 1, then it's basically the cheap quantity or the quantity of the cheapest product. And finally, we also need to find out the imbalance ratio, where the imbalance ratio is the quantity of the cheapest product. So that divided by quantity of the most expensive product. Copy, paste it here. Then we need to also round the imbalance ratio to two decimal places. If you see, imbalance ratio is cheapest quantity divided by most expensive quantity. So you round this entire thing to two decimal places. Let me just, let me bring this down so that it's easier for us. Round this entire thing to two decimal places, and let's alias this as imbalance ratio. Okay, I think this looks good as of now. Let me go ahead and run this, and let's see what do we get in our output. Okay, what do we have here is, we have for every store ID, what's the most expensive product, what's the cheapest product, what's the most expensive product quantity, the cheapest quantity, and the imbalance ratio. Now, what we can do is, we can save this entire information and finally go ahead with the output part of it. So CTE2. Now, what we need is, if we look at this, in the output, you only have store ID as of now, right? But in the actual output, you need the all the information of the stores. So store ID, name, location, all these three columns come from the stores table. So you need to make sure we perform a join. So from this common table expression 2, let us perform a left join of the stores table aliased as S on cte2 dot store id is equal to s dot store id. Give me all the columns from the stores table, and then from the city part, or the cte2 part, second common table expression, what all columns do we require? We require what's the most expensive product. So it's written exp, right? So here we can just rename to most expensive product, and what's the cheapest product, and the imbalance ratio. So let us return cte2 most expensive product, cte2 cheapest product, and then CTE2 the imbalance ratio, but only for those where quantity of the most expensive product is less than the cheapest product, right? You have not considered that factor as of yet. We considered that at least three different products in a store, but we have never considered yet that only those stores are eligible where the quantity of your most expensive product is less than the cheapest product's quantity. Right? Then only inventory imbalance makes sense. So, where your expensive quantity is less than the cheap quantity. Okay, and finally, we need to order by CTE2 dot imbalance ratio, and finally S dot store name in ascending order. I think this looks good. Let me go ahead and run this. Let's see what do we get in our output. Okay, the reason why it says wrong answer is because we missed this part, right? Descending order. It should be imbalance ratio descending order. Let's add that and run this again now. So you see, now this is accepted. If we look at our output is exactly same as expected output. Let me go ahead and submit to see if passes all the test cases or not. So yeah, this is accepted and this is how it. So yeah, very tricky question. What we basically did was, firstly, we arranged by price for every store ID to get the most expensive rank and the cheapest rank. The reason we did that is so that we can easily find out what's the most expensive product, what's the cheapest product, what's the quantity of the most expensive product and the cheapest products, right? And then we calculated the ratio of those quantity and called that imbalance ratio. Once we had all those information, we also had to make sure that we are only considering those stores where at least three different products are there. So we used this line to make sure that it follows. Finally, since we need all the information from the stores table, we performed a join and also made sure that imbalance ratio only makes sense where your quantity of the most expensive product is less than the quantity of the cheapest product. So we made sure of that, and finally returned the table ordered in a way the question was asking us to do. So yeah, this is how we do it. Let me know if there's a better, more efficient solve this question. Let the solution be in the comment section below, and I'll see you guys in the next video.